Without further ado, I want to hand the floor to Marc, who's presenting about blockchain's evolution of DNS.
Okay, so if you haven't figured it out by now, I'll just preface it with a caveat that I'm relatively new to all this. So and some of what I talk about, after going through the last couple of days, could be a lot of second layer stuff. And some of it could be, maybe there's a profound misunderstanding on my part on the part of how smart contracts work and things like that. But it won't take long, and I'll just sort of, blow through how I see this coming from like the legacy DNS world, which we're using to sort of pin up the internet so far. So when I first got into Bitcoin, my big thing was eliminating DNS as a vector of attack for DOS attacks. Okay, that was my sort of, if I could do that one thing, I would be in a much better, place psychologically, because, when you take out one of those nodes in the inverted tree, everything below it does go away at an operational level. And what has happened to me over the years, we manage about 300,000 domains now. Everything from City of Toronto, Province of Ontario, Toronto Police Force, Meta Filter, Zero Hedge, all that. We're down, they're down. It's not great. Traditionally, you try to get redundancy, multiple name servers, anycast deployments, DDoS mitigation, like scrubbers and inline devices like Cloudflare, stuff like that. But what we find is every DNS solution is a single point of failure unto itself. Okay? There's always a bigger DOS, there's always a bigger botnet, someone's always got more firepower for them. You're always fighting the last war. Okay? In another presentation I did, I had a slide that showed the magnitude of DOS attacks, and it's like the price of Bitcoin. It's just so what we found works is multiple disparate DNS solutions. Okay, so unrelated DNS providers. So then along comes blockchain, right? Which to me is the ultimate redundancy. Because to take out the blockchain, you have to basically you have to 51% attack it, really. So, my early idea when I started thinking about this was to use it like a look-aside. In the early days of DNSSEC, before all of the registries were signed, if you wanted to sign your zone with DNSSEC, but your parent wasn't signed, it was useless. So they created like a look-aside registry. You could configure your name servers to say the parent's not signed, look in the look-aside, and then you can establish a chain of trust that way. So I thought, hey, what if I just started putting NS records into a blockchain, right? And then if the name servers are down, you're configured to say, hey, I'm going to check the look-aside and see if the name servers are there, and then it would sort of get me through the DOS attack. And then there are early proof of concepts. There's Namecoin. NeoDNS might not be as well known, but a guy came out and he posted something that was, along these lines, like let's use a blockchain instead of a root, and anchor our domains into that. So, and then it suddenly occurs to me that you don't even have to pin your delegation to your name servers into a blockchain. You can just start putting DNS resource records into the blockchain. And that was kind of a revelation for me, because that was serious redundancy. But that's not the only reason that I got interested in all this. The other incentives to layering DNS on a blockchain is that, as I understand it, I don't know, maybe I'm partially wrong, but smart contracts mean that you can put programmable processing logic into your DNS responses. And there's a phenomenon called BRM, which I'll talk about in a minute, which is neither a DNS or a blockchain thing, but I think it fits in. And the other thing that made this really interesting to me is because of the way Ethereum is built, the Ethereum virtual machine, what we actually have almost stumbled on is that everybody who who's connecting to the Ethereum network has visibility into the .eth namespace right now. You don't have to worry about getting into the legacy root or getting into the next ICANN expansion. The next ICANN expansion is like 2020, 2021 at the earliest, and then figure a couple of years for actual rollout. So you're waiting for that, you're into the mid-20s before anything's going to happen. But, like I said, we're all on Ethereum, and Ethereum has the virtual machine that everyone connecting to it uses, so you can actually see these namespaces now. And also, the other thing that I think makes this very interesting is that the last major TLD expansion in ICANN was just so one-dimensionally non-interesting. It bored me to tears because it was all register your name. You know, you're a doctor, so you should register a doctor TLD, and you know, get this shiny new, brand new TLD before somebody else does. There was absolutely no innovation in why a new namespace will exist, and I think with smart contracts especially, you can innovate out the wazoo. You can have top-level domains where the actual human-readable strings going into it are almost meaningless in the sense that it's really only limited by the imagination. And I call this whole phenomenon that I think typified the last name expansion is that the big fallacy is confusing the map with the territory. The domainers would say, the joke I always use is, how can I be bankrupt? I own $1 million.com, right? It's like, you know, you confuse the symbol with what it symbolizes. You think, well, if I own doctors.com, I'm automatically going to lock up that vertical, and I'm going to have the category killing domain. We observed this yesterday. We talked about the generic name doesn't win brands. The brands define the generic space. It's actually backward. Anyway, so bringing the BRM into this, I don't know how many of you know who Doc Searles is. He wrote a book called The Clue Train Manifesto in like '99 with a bunch of co-authors, and it kind of like, you know, sort of defined the coming .com generation. And in 2012, he put out a book called The Intention Economy. And the whole framework around the intention economy is what he calls VRM, Vendor Relations Management. He called it that because he says it's the inverse of CRM. You know, everything now is CRM, Customer Relations Management. You're living in somebody else's walled garden. Your data becomes their commodity, and you're being monetized by them. And what he talked about in this book was a philosophical attempt to flip that on its ear and put the consumer in charge. So it's my data, it's my application, it's my, you know, contract that I'm putting out for you as vendors to compete over on my terms. And the word blockchain or Bitcoin doesn't appear anywhere in that book, but once I came across this, I thought these two should, you know, should be introduced to each other, these two concepts. So an example use of like a VRM type application in the namespace would, you could even do this as personal TLDs. That's why this sort of subdomain thing sort of confused me and I sort of got it. But you would have different zone cuts under a given label, and those zone cuts that each have really high-end fancy functionality to it that goes beyond what is doable in the traditional DNS space, where you can get an IP address back, or you can find out where to send an email, or where to route a VoIP call, or set up a SIP session. But you know, and that gets fancy enough. But when you add the smart contracts to it, as I understand it, you can get really fancy, because you can then say who gets the data, when, why, how long, for how much. You can even start collateralizing it or tokenizing it. So why I think this can succeed where previous naming initiatives have failed is because the old naming initiatives sort of, it wasn't enough of a reason for someone to download a browser plugin and plug it in so they can see a bunch of new domain names, right? Ethereum exceeded that. it wasn't about naming. The naming is sort of a side effect, and that's how I think it overcame that critical mass, because now more and more people are connecting to the Ethereum network for other reasons, and as a side effect of connecting to that network, they're going to have this visibility into these alternative namespaces now, not later. So almost, it's the word I'm looking for, by accident, solved this big hurdle to expanding namespaces outside the ICANN process. You can have ENS serving as a blockchain-based group. You have a big enough blockchain to prevent DOS attacks against the chain itself. Take a 51% attack to take it down. And then eventually you could have side chains off the root chain. And those would be like the equivalent of, new TLDs. You have different governance models, different reasons for existence for different TLDs. I mean, one collateralized, that's like, as I understand, like a Dash master node. Just sort of like the miners have an incentive to sort of maintain that node and put more computing power into it. And then again, what are you going to use these new TLDs for? I mean, the examples I always rip off: GPS coordinates, RFID tags, IoT identifiers. They can all be under their own separate namespaces, and sort of take that whole who's going to get business.iot. It doesn't really matter, because that's not what you're using that namespace for. You can build a better mousetrap at the registry level, like for CCTLDs, GTLDs. You can pin the name server delegations directly into a blockchain. You can make the blockchain more resilient than their actual current name server configuration, and you can make transfers and things like that safer, easier with things like multi-sig and things like that. And then posting TLDs, I mean, that could be a thing. Who knows? This is something I thought about before I came here and was talking to you guys. Just in my mind, the economic incentives and mechanics. You could chart. It would cost you to put DNS resource records directly into the blockchain, right? It would cost you to change your update resource records. In that scenario, companies like mine actually lose a bit of relevance as authoritative DNS servers, because people would be bypassing us to put their resource records directly into the blockchain. You still need resolvers in the legacy DNS context of it, like the name servers that just go out and find answers for you. I think in a scenario like that, authoritative DNS operators would probably drift towards mining and maybe custom smart contracts, and just sort of acting as a user-friendly interface between the end users and what they want to have happen with their naming assets. Would you create, over on the legacy DNS side, does it make any sense to create new DNS resource records that sort of point in toward the blockchain ecosystem? There already is a proposal called PMTA, which is a payment type resource record. It's a joint thing between VeriSign and Armory, and it works in conjunction with Dane. My concept, I just call it TOK pointer, like a token pointer, which basically you map, some address in DNS host space to a cryptocurrency, a subtype, and then that, the actual address. Dane is already happening in the DNS world. It's DNS-based authentication of named entities. It's a replacement for what we used to call SSL. We now know it's TLS, and it's basically doing TLS without a central server authority. I don't see this as any of this as a replacement for DNS, right? I see it as sitting on top of DNS. I call it like the level of signal on top of the internet of noise, right? With possibly an eventual integration into the legacy root, but it actually doesn't really matter if it happens or not because of the way it's architected now. So that's my Q, McLean, gate, and void type characterization of the internet today. We've got a big fat thing of noise, and then a little tiny bit of signal on top, which is like the actual intelligent communications you want to get. And that's it, really.
questions?
So Mark, do you see this as not trying to be a new like TLD registrar for existing domains that has a separate name server built on top of Ethereum, right?
So I think existing TLDs could, in time, say, you know what, we're going to put our root on the blockchain, right? We're going to put that top level zone on a blockchain, the blockchain, a blockchain, a specific blockchain. I don't see this as coming along and saying, well, we're the new .com and everyone's going to start using it. I don't see that happening. But what I do think can happen is that a new set of TLDs within Ethereum, like .eth and maybe some others, could actually spring up with their own sort of mandates and governance structures. I think this will evolve over time. I'm not saying it should happen now. And whether some of them will ever come down into the legacy root and have that global visibility, it may not, but what I find so interesting about it is it's not necessary. So if it doesn't happen, it doesn't kill what's happening, like in this room, in this whole phenomenon. Does that answer your question? Or?
Yeah.
Okay.
And do you think it would already help against denial of service attacks if, say, we implemented this, we patched binds reading from the blockchain, we can set the name resolver for some domain that I currently own to resolve it with blockchain? Will that already help prevent some denial of service vectors? Or
I think it would. I mean, if you had enough of uptake on the resolver side, right? So let's pie in the sky for a minute, open DNS, Google public DNS, say, yeah, you know what, we're gonna support this. Then yeah, it would be a big deal, I think.
I think the implausible we get that because I mean, so binds can support things like OpenNet. I mean, you still have to set your. And I think it's more plausible that will, I don't know what. I guess someone will operate an alternative route that makes all the Ethereum TLDs work, and then people point to the alternative route, which would be awkward, but that's more plausible.
Yeah, I mean, you know, people are already working on things like Power DNS pipe backends that can sort of see the .eth namespace now. So if you're running those resolvers or using those resolvers, then you can see them, right? Another thing that I think might become more commonplace in time is I think there's going to be more people running personal resolvers, and those resolvers can be configured to look at whatever namespaces you want. Because that's, at the end of the day, the legacy root is all consensus, right? If you switch the root hints in your laptop, you can look at any other set of namespaces you want. But what's unique about Ethereum is that it's already got this momentum that can do that, which can do the same thing, which has never existed before.
So the proposal is that what the ENS Foundation runs an alternative.
Well, there's a couple of different things. So part of it was
That's very bold. I mean, it's not off the table, but
yeah. No, I mean so one proposal is that we think about creating a structure where different TLDs with different governance structures can and so this is where I get confused because I don't know. I don't think I fully understand the architecture now. But where does the mandate come from for .eth and ENS to even exist? Like, who authorized it? Where did it come from? Or did just a bunch of guys get together and write a contract, right? So, yeah, that's what happened. Okay, so a bunch of guys can get together and write a contract that does something else too, right? Yeah. So at that point, you know what I'm proposing. So. Other than when we talk about the protocol development of ENS, that it has, see, I guess I sort of fixate on the ability for legacy DNSRRs to be visible inside ENS and for ENS to be, and then to be able to bridge back and forth between the two, right? That's why yesterday I was saying, is it possible to add an extra parameter to the resolver call because signal more information that you want about the client. So that's the kind of thing that I think about. Whether it would be like a completely, I guess it wouldn't be, sorry. I was just going to say, like, would it be a separate blockchain, or would it just be something on Ethereum? It would just be
Something on Ethereum. Yeah.
It
Just
could be
be on Ethereum.
Yeah, because then that's big enough, right? It's
Yeah.
big enough to do it.
And it can be something on the existing ENS route. It doesn't need to be a new ENS deployment either.
Right.
So I guess this would be a good time to recap the current state of the art for ENS-on-DNS, so DNS-on-ENS, which is almost nothing. But I wrote the concept a while ago, and the ideas there seem worth using as a starting point at least, even if they all turn out to be terrible. Basically, one approach is that you define a new resource, a new record type for ENS resolvers that returns a serialized zone file, effectively a binary zone file for size reasons, because it's the blockchain. And that resource type is looked up just like any other, like address or a name or ABI, given the node that you're looking up, and that stores standard legacy DNS records. So for looking up .eth names, that would mean that anyone who has a gateway to DNS that knows to look at this this top level registrar, the top level ENS registry, can then do RR set lookups on that name, get back a serialized zone file, and then answer questions from that zone file just like they would any other DNS name. So you have a proxy interface. The other approach, which I didn't take in my experimentation, but is plausible here, is that instead of storing serialized RR types, you go through each RR type and you define its own function on the resolver that it can implement. It returns, 0 or more entries for that particular thing. So we would have an A function and a C name function and an A name function and an X function, and so on and so forth. And in my mind, at least, they both have pros and cons. The former is much simpler and imports a sort of 100% compatible version of DNS into ENS, but it is very much encapsulated. It means that if we did want to, like you suggested earlier, resolve ENS resources such as addresses through a DNS RR type, you'd have to special case that. You'd have to say if the query is for a token type, then go look it up via the traditional ENS resolution. If it's for anything else, then go fetch the zone and pass the zone and so on. Or you need to duplicate everything twice, which is prone to errors and discrepancies. And then the other end of things is whether ENS could add traditional TLD routes to its set of internal routes. And this is something we discussed briefly yesterday, which is the idea that ENS could cooperate with an existing top-level domain registry and say everyone who buys a .cooking domain now gets a record in ENS as well, where they can host stuff. And to take it a step further, everyone who buys a cooking domain, all of the glue records at a minimum are stored in ENS, and if you want, you can store your own zone files there as well for subdomains. At which point it becomes a fully sort of ENS-enabled DNS system, and anyone who knows about this delegation for .cooking can do the resolution themselves instead of having to fetch it over the internet and be subject to both DOS attacks and so on, and the possibility of of corruption if they're not using DNSSEC. You could get all the effects, to the best of my knowledge, of DNSSEC just by virtue of being signed on the blockchain. And you can go a step further and you can embed your SSL certificates in ENS, and then you can get SSL without a certificate hierarchy and so on as well. Yeah, so I think there's lots of territory worth exploring here, because I think the benefits of doing this in a way that is sort of harmonized with existing DNS TLDs, if possible, would be pretty awesome. Does that seem like a fair summary from your point of view as well?
Yeah, but what about the scaling?
So maybe this is a good time to address.
No, I'm right over my head, so.
So I see there's like several, so there was like at least 2 projects here that I think we could do it in parallel. I guess we can prioritize among them. Personally, among the list, okay, wait, let me read the list. The first one was you have an ENS-able TLD. The second one was we have a layer. How did it work? How do you say it? So you're importing raw DNS records into ENS, and so when I do a lookup for foo.eth, an appropriately enabled resolver will know to look it up and then return appropriately.
Yes, but I don't think those are alternatives. Those are two aspects of the same proposal.
No, I see these two as in parallel. I mean, I see these two as orthogonal.
Okay.
Are they not?
Independent, not mutually exclusive,
Yeah, correct.
but not mutually reliant either.
Correct.
So both of them are basically about putting DNS records in ENS. Are you suggesting a situation where you can put your second level domain in ENS without the root being aware of this, or are you?
I guess I'm proposing if you had, so I guess if you wanted to add DNS records to your foo.eth, and if someone said, oh, tell me the MX record for foo.eth.
Yeah.
A typical resolver would not know .eth,
Right.
But one of them might. And if so, then you could look it up that way.
Yeah, so there are two things we can do. We can integrate existing TLDs, which will then be accessible on both, or we can aim to add DNS functionality to .eth with the knowledge that it will only be resolvable by those that support.
By those weirdos.
Which is more, just more or less what you were talking about.
Right, so like, let's say, MetaMask says, you know what, if someone types a .eth thing into their web browser, I know how to find that record, and I know how to find that A record and get them there.
But I think that
Wait, MetaMask, could you do that?
Not with the current web extension API, but there's like.
That'd be really cool.
I know. Brave is interested in doing
Or
unique
missing
things. So yeah, we're talking about that. But some browsers move faster than others.
Okay, but I think you're
I would
saying,
love to.
okay, and this is like within the realm of tractability?
MetaMask would have to be the thing to
Work
do
in
it.
progress.
I mean, you
We're
could.
working in progress. Yeah, call that a work in progress. Like currently technical.
So will work in practice.
Oh, would work in practice? Kind of. I mean, there's also the question of like the prefix, like if it's not HTTP, right? Are you doing a swarm resolution? Are you doing IPFS resolution? There's like a lot of different protocols involved in like, so what are you actually resolving? There was an early suggestion like if you typed in the thing, maybe it would show you some basic information about it. Maybe it would show you, maybe it would take you to the registrar site. And
So it also look like an explorer or something.
right. I mean, maybe we do something really opinionated.
Well,
like
I mean, so if you're doing HTTP, like, in front of the URL, that's a specific meaning, that's calling a specific thing, and part of that process is you do an A record lookup, and if you get a C name back, you repeat it, right? So you just sort of follow that spec, and but except you can do it for .eth. You can say, well, it's HTTP, but it's .eth. So if I do a straight DNS call, it's going nowhere. But you have the ability to look straight into blockchain, or if more people start setting up name servers that actually know how to handle the .eth, but you're uniquely positioned, this is uniquely positioned, all the browsers are uniquely positioned to say, hey, yeah, we know what to do with this. We don't have to do a DNS lookup, but we can get the result off of DNS, and then we can format it back the way it would expect it at the end of the DNS lookup, and then the browser just keeps over.
And of course, this can be done right now without external browser by running your own local resolver.
Sure. Yeah.
Or running a SOX proxy or your ISP DNS.
But a lot of that hurdle is gone because of things like NIST and MASC. Yeah, all of them.
Okay, but those are the two thrusts. Are there any others?
Well, one was, you convince a TLD to say we're going to move to a blockchain route.
So that was one of the.
Yeah, that was the first one.
Yeah.
And I think
Local resolver.
those two look the same technically. In either case, you have some form of local resolver that has a list of TLDs that it knows it can resolve through the blockchain. And it doesn't really care whether that's .eth, which just doesn't exist outside the blockchain, or whether it's .shopping, which has decided to cooperate and is available on those.
And then there's the stuff making ENS more DNS-like in terms of the way that the queries are made and the records go.
And exposing ENS records. The third one, I guess, is exposing ENS records on DNS, which I think is a much more marginal use case personally, because if you need to resolve it via DNS, then
DNS records on ENS?
No.
so being able to do a token RR type lookup to get back a token address using DNS.
We either have to propose and have it accepted, like a new DNS RR type, or you just, you always just punch it into a test record, but people kind of jerry-rig for all kinds of uses.
But I personally view that as a much more marginal use case, as I can't think of many cases where you want to look up an Ethereum address, but you don't already have an Ethereum chain to just ask yourself.
Right. There's one like, you know, it's the old ICO hack, right? When you're on the website and you look at the address and you can get two different points of reference, right? You can assert a host name and an address on the thing, and then your DNS can verify it to say, look, there is a text record at this host name that's putting out, asserting the same address that this thing is telling me to send my ether to.
That would be more useful with it if you were hosting a site on a traditional DNS service that doesn't support blockchain integration. You want to assert something about your blockchain address there.
Right. So that doesn't that fit the sort of marginal use case of getting that data, those addresses out to the real.
But that would be explicitly for providing integration in the other direction. So I'm using .com hasn't blockchain integrated, but I still want to be able to say something about where I am on the blockchain from the DNS there.
Yeah. So you would need
So that's
text
pretty
record or
here.
yeah.
How naughty is it considered? So, I mean, say we just decided to add a new token type R record and we just did it. How much would that like irritate people?
Well, you just started creating name servers that could understand it.
Correct.
You know, I don't know. I can't really speak for the community. I mean, there's some people.
I mean, it would obviously tweak them. So, like, I mean, like, would it be like we find you mildly irritating, or we find you blatantly offensive?
I think there would be some pushback that there was no attempt to go through the standards track.
All right, fair.
And so that might hamper uptake down the road.
All right,
Everything's got to go through the standards track. You know, and you can propose anything in the standards track.
So we could bend the knee.
Yeah.
All right.
Do you know how AWS does their alias records?
It's a C name flag. So they just basically resolve the C name, they turn it into an A record, and put that. That's how everybody does it. That's how we get it.
So that's conforming to.
Well, there's actually no standard for that.
Okay.
Right? So there's actually a section in my book that goes on for too long about, you know, C name flattening and C names at the zone apex, because it breaks standards, right? You're not supposed to do it, but everybody wants to be able to do it. It's the one rule everybody wishes they could break the most. So the way everyone does it is you resolve it, put it in an A record, but then you're not done, because then you have to, if the endpoint changes, you have to monitor it. First, if it itself resolves into a C name, you got to follow the C name chain until it terminates. If it's a round robin record, you've got to round robin it. If the endpoint changes, you've got to monitor it. So it's like dynamic DNS in reverse, right? From the other side.
So normally this session, our goal is to elaborate on technical aspects of DNS integration.
Also, sorry, to your point about, do you serialize the zone file and hand it back?
Yep.
Or do you do it for each record? So if you do a function for each record, then if you got to keep track of new resource types as they come out. Although you could do the same thing resolvers do, which is if you get a type code that you don't understand, you just pass through the error data, like you just pass through the integer type code and the error data, you don't try to do anything.
And so in fact, there is a third option there, which is that we provide a resolution function which takes basically the whole query as separate parameters. So you make the resolver responsible for answering DNS queries rather than returning zone files.
Yeah, that's like, if you look at Power DNS, the way they've built their whole system where you have different DNS backends and then they've got this core engine. So everything to the Power DNS backend is any query, right? We lost a lot of programming time once because we're like coding something and we're like, how come it's like we want to see the queue type here and we don't see the queue type, and Bert started yelling at me because I didn't get it. So it's always an any. And so the backend pipe will return all the records that match the query name, and then the core engine's then going to sort out to say which of these records am I going to return based on. It's very similar to what you're talking about. Right? So you get everything you got, and then say, based on the query logic, what am I going to return? Yeah.
And so we could specify a similar API for the DNS resolvers, which says you're effectively answering a DNS query, but we promise that they'll be easy ones. We'll simplify the query by saying you're only ever going to be asked for any. We won't even specify that, just return any for. Here we give you a name.
Yeah.
One of the problems though is that the ENS model and the DNS model for how names are resolved is quite different. DNS operates on zone files, and you have zone boundaries, which are not necessarily every subdomain, whereas ENS treats every name as its own domain, its own zone, effectively.
Yeah,
so we have
getting that. There's like a zone cut between every dot. Yes.
Exactly. So.
So in the regular DNS, there's only a zone cut if each successive level has its own set of name servers.
Right. So in ENS, each of these is actually just a record in a table. And my mark is getting out again, never mind. Each of these is a record in a table that has an owner and a resolver, and that's it. So it has no concept of zones. You can always take a compound name, turn it into a main hash, look it up. DNS, though, has zone files which can incorporate multiple layers of the hierarchy. So we might have a zone file for the root, a zone file for ETH, but then a zone file for nick.eth and wallet.nick.eth and arbitrary ones. And it only gets delegated when you encounter, if I remember correctly, an ENS record, and then the root of the next one has to have an SOA record and so forth. And so one of the problems with trying to build a binding for DNS and ENS is how we handle the zone file issue, or the zone boundary issue, because...
See, that's what was tripping me up during this entire talk about subdomains, because
yes.
I'm like, well, where's the zone cut?
Yes.
There is no zone cut.
Exactly.
So
if we take a naive approach, then you may end up in a situation where if we have this zone starting at nick.eth, and I go along and go, okay, I want to resolve wallet.nick.eth. The name hash for wallet.nick.eth is blah. Go to that thing, ask it to resolve a name, and it goes, I don't know anything about DNS. But what I should have done is gone to nick.eth and then asked it to resolve wallet.nick.eth, and it would have gone, oh yes, I know about that, because this is the root of the zone file that is responsible for it. And possibly this is a non-issue, because if we follow the DNS resolution paradigm, exactly, you would never look up wallet.nick.eth using DNS directly, because you would follow it from the root. The root would say go to ETH zone, and the ETH zone would say go to the nick zone, and then we'd resolve it there, and we'd never go any further. So I guess, I guess an open question is how much of a mess this is going to create, though, especially when you get into resolving subdomains and ENS native resources. Like if I ask for the token record of wallet.nick.eth, so I'm looking for an ENS native record. Who do I ask, and what do they answer?
It depends where you are, right? Like, are you unique from within the area ecosystem, or from out in the world where you're like, you know, typing it into a browser, or?
Yeah, so say I type into a browser, give me the token R type for wallet.net.eth. If I follow the standard resolution thing, then this record here is responsible for answering. But if I just did an address lookup for wallet.net.eth in ENS, then this record is responsible for answering.
So, yeah, I mean, if you're in Mist or you have MetaMask and you type it in, it's like it would sort of, maybe you would have like, it's your you know, your resolver order almost. It's not that one, there's a different, you know, where you say files, hosts, DNS, like which mechanisms to try in what order. So you can say, you know, start on the blockchain, and if I don't get an answer there, then look here, or vice versa. Right?
But the concern is that if you change the method of resolution, then the entity responsible for answering it could change, and you could get a different answer to the same question.
Well, that's not supposed to happen.
Yeah, exactly. Can I just briefly poll, how many people here find this a valuable discussion for all 27 of us and want to continue it right now? And how many would prefer to move on to a topic that, because I get the sense this may engage a small subset of the people here, but I'm not sure if that's true. So who here would prefer to move to another topic?
What are the other topics that we've been moving to?
Yeah, so it's a good question. That's a fair point.